So ratios and proportions. Now in ratios and proportions, first we have to understand what is a ratio and what is a proportion. So first we will understand what is a ratio. Okay. Now the ratio is the relationship between two quantities of the same kind which can be compared in two ways. Okay. So the relationship between two quantities of same kind. You cannot compare different kind of quantities, but if you have two quantities of same kind, then you can compare them. Okay, I can compare the students' marks. I can compare the class marks. Class of BCom, class of BBA. First semester BCom, first semester BBA. Third semester BCom, third semester BBA. I can compare because you all are of same kind. You all belong to a particular semester and it's all of same kind. I can compare the marks of a student in test 1 and test 2. Now the test is same kind. The two quantities are test 1, test 2. Okay, so the relationship between these two quantities of same kind, when it is compared in many number of ways, that is known as ratio. Okay, now in that we have two ways of comparison. Let us learn the ways of comparison. You will not get problems from the ways of comparison, but then when we come to ratio, we will be able to understand how ratios are utilized. So first one is difference method. The next one is division method. In difference method, quantities are compared as one quantity is more or less than other quantity. So when we compare two quantities saying one is more than the other, or we will say one is less than the other. So that is how we are showing the difference. So let us see the example here. Given the two quantities, say marks in quantitative analysis. This is a subject. It is nothing but maths. Okay, suppose the maths marks of two students A and B are 60 and 90 respectively. So A's marks is 60, B's marks is 90. Okay, now if we are comparing these two marks, how are we gonna say that in a sentence? In numbers, we can just know, we can know it easily. 60 is less, 90 is more. Okay, but how are we going to say this in a sentence? Student B has scored. Who is student B? Student B is here and has scored 90 marks. So student B has scored 30 marks more than student A. So the difference between two of them is 60 and 90. And we are saying that student B has scored 30 marks more than student A. On the other way, we can also say this as student A has scored 30 marks less than student B. So if you see the first sentence, the comparison is on the greater side. That is, we have taken the person who have scored more marks and we are comparing it with the person who has scored less marks. Right? So student B has scored 30 marks more than student A. So the other way of representation under difference method is student A has scored 30 marks less than student B. So student A's marks is 60 and B's marks is 90. So 30 marks less. So this is difference method. We are showing the difference in a positive way here. Okay, so that is difference method. Now the second one is division method. Okay, now under division method, the same students' marks will be shown in the form of a ratio. Now we are comparing the marks of A and B, but the representation of the marks will change a little. Now let us understand how that will change. Okay, under division method, marks of the students A and B are compared with a representation of 60:90. So we are taking this 60 and 90 in the form of a ratio. Okay, A is to B. So 60, A's marks is 60, B's marks is 90. Okay, now if you simplify this, you will be getting 1:1.5. This is one way of representing 60:90. This is another way of representing. And there is one more way of representing it, that is 60/90, A by B. Okay, when you divide A by B, you get 0.6666. 60/90, if you do, you get 0.66. Now, how do we say this in a sentence? Student A's marks are 0.666 times of marks of student B. Now, we have made an effort to represent it in the sentence of this form here. Okay, so but here we have directly considered the marks, but in division method, we are considering after dividing the marks. So, student A's marks is 0.666 time of marks of student B. Okay, on the contrary, if you do it ulta, if you divide it on the opposite side, 90/60. Now in 90/60, 90 divided by 60 you can consider. And again in this, if you see, it is 1.5:1. Okay, so in this is one way of representing, that is 90/60. The other way of representing is 90 divided by 60. The other way of representing is again 1.5/1. We are just reversing the same numbers here. Okay, so one is difference method, the other one is division method. Next, the comparison of quantities of the same kind in the division method is known as ratio of two quantities. Okay, so the comparison between two quantities, that is A and B, of same kind. Now we are comparing marks of two students which is of same kind. Correct? So that is known as ratio of two quantities. Did you all understand till here? Any doubts? We have difference method, we have division method. Any doubts until here? We understood the background. Now let us understand the meaning of the ratio. Okay, so meaning of ratio. If A and B are two quantities of the same kind, then fraction A by B is called ratio of A and B. So we already understood how it is represented using the formula of the marks of A and B. So if A and B are two quantities of same kind, the fraction A by B is the ratio. So therefore, ratio of one quantity to the other. We are comparing two things here. Ratio of one quantity to other in relation to respect of number of times one quantity contains. So when we compare, we can also compare them in the quantity wise, where we are saying that, okay, one quantity is containing more than the other. It is usually expressed in the fraction format, or you can see the format which we saw here directly in ratios. Okay, you use a colon here and you represent the numbers, that will be the ratio. So simple meaning that you'll have to understand is if A and B are two quantities of same kind, the fraction A by B is called ratio of A and B. Now, moving further, how do we represent this and what are both of this A and B called? Okay, now the ratio is usually represented as, in a sentence they will say as the ratio of A and B, or they will say it as A is to B. If you write in a sentence the ratio of A and B, we will get statement questions. So where we will have the ratio of A and B. But if they're giving it in the numbers, they'll just give it directly, which is ratio of A is to B. Now, when you have this colon here, we represent that as is to. Okay. Or the other form of representation is just division, A divided by B. This is very important to remember because we'll be using this in the questions when we solve it. So first one is the ratio of A and B. Second one is A is to B. Third one is A by B. Now this A part, whatever you see in all the three forms, this is called as antecedent. This is the first term of the ratio. Okay, it can be called as first term or it is called as antecedent. And B, whatever you see in the three forms, is called the consequent. It is the second term of the ratio and it is called as the consequent. So these are the basic things that you'll have to understand about the ratio. It is a comparison between two quantities of same kind. Okay, if they ask definition of ratio, you can write this, which just means same, whatever we have studied until now. It is just the repetition of that given separately. Okay, now here they have just told that ratio is the comparison of two units of same kind but expressed in a arithmetic form. Now expressed in the same kind is okay, but we are doing maths, right? So we have to express that in the numbers and in the arithmetic form so that we are able to compare them and get some conclusion. I hope you all understood until here. Any doubts? You want? Now moving further, some important points relating to ratio. So we'll have to understand these 5 points before we start solving the problem and understanding different forms of ratio. Okay, so the first point is the terms of the ratio must be of same unit. So that is what has been clearly told to us from the beginning, from the background, from definition, meaning, everything. What it says is that we are supposed to express the terms of ratio as the same unit. Now, for example, when we are expressing the ratio between the marks of two subjects or the marks of two students in one subject or the currency between two countries, okay, or the quantity between two products, and that product's quantity should be given in the kgs only or quintals only, tons only. Okay, they have to give the similar kind of weights. Okay, so that is the same unit. But if at all they have given the terms or the weights or the units differently, if they've asked us to compare the marks of the student and the income of the student, it doesn't make any sense because the comparison or the ratio whatever we form does not make any sense at all, right? So we have to understand, if the ratio is between marks of the student or it is between two test marks or marks and some other thing that has been added to that, but not the haphazard comparison. Okay, if I compare the marks of a student and the amount of food the person eats, is there a comparison between those two? Absolutely no. So you have to compare two units of same form there to form a ratio. Okay, so that is the first point. Then ratio has no unit of measurement. Usually when we solve the problems, we would be getting the problem saying hours, kgs, rupees. Okay, but the final answer, you should not add any of these units to the ratio. Okay, now if you see here, the marks of two students is 60 and 50. Now 50 marks and 60 marks can be written in the first time, but the final answer is supposed to be 50 is to 60. Okay, 50 is to 60. That should be the marks that has to be utilized or represented at the end. So the ratio has no unit of measurement. Then a ratio remains unaltered if its antecedent and consequent are multiplied or divided by the same scalar number. Now let us take the example here. We'll take this number as example. Okay, so 2000 is to 4000. In this, the first term is called as antecedent, the second term is called as consequent. Correct? The first term is called as antecedent, the second term is called as consequent. Now, if we multiply both by 2, let's say we are multiplying both the numbers by 2. So what do we get? We get 4000 and we get 8000. Okay, correct? Now, if I divide this ratio, by 4, what do I get? I get 1000 is to 2000. So what are they trying to say is, you can multiply the ratios by a scalar number. Scalar number is one number. So you can multiply a ratio by scalar number, it will still be same. Now this 2000, uh, 2000 is to 4000. Let's say if you simplify this, I can say 1000 is to 2000, which in simple says 1 is to 2 ratio. Okay, now if I multiply it with 2, 4000 is to 8000 also is in the ratio of 1 is to 2 only if you simplify it. Okay, now if I divide this ratio by 4, again I get 1 is to 2 ratio only. So if a ratio is multiplied or divided by one number, the same number has to be multiplied for both the ratios, and the number, you can also divide the ratio by the same number. Now in all this case, the ratio will not change, it will remain same. I hope you are able to follow. Okay, the ratio is not changing, it will remain same. Now the next point, generally the ratio is expressed in its lowest possible unitary terms. Now if you take this number, 5 is a prime number, but 6 you can reduce it. But since both the numbers has to be reduced, you cannot do anything. Just take out the zeros and represent it as 5 is to 6. Okay, now if you see 2000 is to 4000, which we just solved, you will get 1 is to 2. The lowest possible uh, simplified way you have to represent the ratio. That is the next important point. Then, to compare two or more ratios, convert them into equivalent ratios so as to make the denominations of the ratios equal. Suppose they have given us hours and minutes. Okay, so either we convert everything into hours or we convert everything into minutes and then we solve the problem. If at all they have given two different or two or more ratios are given, and then we have to convert them into equivalent ratios of the same form, and then we have to solve for the ratios. So these are the 5 important points you have to keep in mind while solving the problems of ratios. Any doubts? Did you all understand? Okay. So moving further is the different forms of ratios. So let us understand what are the different forms of ratios. So first form of ratio is unit ratio. Now in this unit ratio, the ratio of equality in which both the terms are equal, which means the first term antecedent will be equal to the consequent, like 1 is to 1, 3 is to 3, 5 is to 5, 10 is to 10. Okay, 200 is to 200 is also a ratio. So a unit ratio is where the antecedent is equal to consequent. And that is called as equality ratio or unit ratio. So this is the first form of ratio. This question of different forms of ratio can be asked for your section B, 5 or 6 marks. Then inverse or reciprocal ratio. Now inverse ratio is that the product of the ratio, okay, the ratio is said to be inverse of the other if the product of the ratio is 1. If you multiply a sorry if you have a ratio a is to b, then how do you say it is also equal to b is to a? Is when you multiply the ratios, okay, you will have to get 1 as the answer. That is when you call them as inverse ratio. Okay, then compound ratio. Compound ratio means when you have more than one ratio and we use both of them to solve it, then it is called as compound ratio. Now here we have a is to b and c is to d. So these are two ratios that we have. Now out of these two ratios, we are multiplying the first terms, that is a into c, and we are multiplying the second terms, that is consequence b and d. So what will be the compound ratio? A is to C is as to B is to D. Okay, that will become the compound ratio. So let A is to B and C is to D be the two ratios. Then ratio of A into C and B into D is called as compound ratio. Okay, so we are multiplying the antecedents together, we are multiplying the consequents together. That is compound ratio. Okay, any doubts until from the first three types of ratio? Any ratio you want me to repeat it again? Okay, now let us go to the next type of ratio, that is duplicate ratio. Now duplicate, subduplicate, you'll have to learn it together. Okay, it's very easy. Duplicate ratio means just finding the square of the ratios is called as duplicate ratio. Okay, when the ratio is compounded by itself, it is called as duplicate ratio. So when you have a ratio 2 is to 3, and when you square them, it becomes 2 square is to 3 square. Okay, so what is the duplicate ratio of 2 is to 3? When you square 2, you get 4. 2 square is 4. 3 square is 9. So the duplicate ratio of 2 is to 3 is 4 is to 9. So that is duplicate ratio. Now coming to subduplicate ratio, in duplicate ratio, we found out the square of the numbers. In subduplicate ratio, we will be finding the square root of the numbers. Hold on. So duplicate ratio is when you square the ratios. Subduplicate ratios is when you find the square root of the ratio. Now, if you want to find the subduplicate of this number, you just have to find the square root of each of the ratios, like square root of A is to square root of B. Okay, so square root of 4 is 2, square root of 9 is 3. Here we are getting it back, reversing it. Understood? So firstly, we will square them under duplicate ratio, and then we will find the square root under subduplicates. That's why it's called subduplicate. So subduplicate ratio will find the square root and will get back the actual ratio. Clear? So that is duplicate ratio and subduplicate ratio. Now moving on to triplicate and subtriplicate ratio. Now triplicate ratio, like how duplicate was squaring of the numbers, triplicate is finding the cube for the numbers. Now the same 2 is to 3, if I find cube, if I find the cube of 2 and if I find the cube of 3, that will become the triplicate ratio. So 2 cube is 8. That is 2 into 2 into 2. 3 times if you multiply 2, you get the number. So 2 into 2 into 2 is 2 2s are 4, 4 2s are 8. And then 3 cube, 3 into 3 into 3. 3 3s are 9, 9 3s are 27. So the triplicate means finding the cube of the numbers. Whatever ratio is given to us, in the same form, we will be finding the root of the numbers. Okay, that is the triplicate ratio. And coming to the subtriplicate ratio, we'll be finding the cube root for the numbers. In subduplicate, we found the square root of the numbers. In subtriplicate ratio, we'll find the cube root of the ratios that is given to us. So if the ratio that is given to us is 27 is to 64, now cube root of 27 is 3. 3 3s are 9, 9 3s are 27. Now cube root of 64 is 4 4s are 16, 16 4s are 64. Okay, so these four ratios are like a set. Duplicate is the square, subduplicate is the square root, triplicate is the cube, and subtriplicate is the cube root. Any doubts until here? Did you all understand this four ratios? Okay. Now, moving to the next type of ratio, that is continued ratio. We have another three types of ratios to understand. We'll finish that off. Continued ratio. When the relationship between three or more aspects of same kind is expressed in the form of ratio, that is known as continued ratio. When they are talking about three or more ratios which is connected to each other, that will be called as continued ratio. Okay, so we are seeing the example here. 3 is to 4 is to 6 is to 8. There are four things which are being continuous here. So there are three or more aspects of the same kind. These may be marks of the students, the ratio of marks of the students in a simplified format. Okay, so like that, when it is connected to each other, then we will be representing them as a continued ratio like this. 3 is to 4 is to 6 is to 8. Or you can also represent them in this way, where you have the first ratio is represented as 3 by 4. Okay, ratios can also be represented as A by B, right? So 3 by 4. Now the second ratio will start from the second part, that is 4 is to 6. So 4 by 6. Then the third ratio will be 6 is to 8. So it is continuous, right? So that's why we are considering the middle two ratios continuously. So this is called as continued ratio. Then the next one is ratio of greater inequality. Now here they're just comparing the numbers that is there in the first term with the second term. Okay, in the ratio, if the first term, that is A, which is known as antecedent, if it is more than B, that is the consequent, then it is called as ratio of greater inequality. Okay, so if the antecedent, the first term is more than the second term, then it is called as ratio of greater inequality. So like example, now 3 is more than 2, 5 is more than 2, correct? So the first term in the ratio is more than the second term. This is known as ratio of greater inequality. Then ratio of lesser inequality. This is the opposite of the previous type. Here, the first term of the ratio will be less than the second term of the ratio. That's all. Okay, here A will be less than B. So that is ratio of lesser inequality. Clear? So these are the types of ratios that we are supposed to learn. They can ask a section B question explaining you, asking you to explain all the types of ratios. Any doubts? Any type of ratio you want me to explain it again? Everybody understood? Good, Rida. Everybody understood? Okay, good. Now, in the next class, we shall start the problems. Okay, we'll stop it here for today and we shall start the problems from the next class.